Hello all, welcome to this channel. Today we are looking at the following number here. It's 11 to the power of n plus 1 plus 12 to the power of 2 times n minus 1, and we want to prove that this number, as a natural number, is always divisible by 133. And this for all natural numbers bigger or equal than 1. So if we insert n here, we always receive a natural number that is divisible by 133. And probably you guess it already. We want to prove this fact by applying the proof of induction method. And as always, we start with the base case here first, which means we look at n equals to 1, and in this case we have 11 to the power of 2 plus 12 to the power of 1, which is 121 plus 12, and this is exactly 133. And 133 is obviously divisible by 133. This concludes the base case, and now the inductive case. We assume 11 to the power of m plus 1 plus 12 to the power of 2 times m minus 1 is divisible by 133 for some natural number m bigger or equal than 1. And now we want to prove that this statement holds true if we replace m with m plus 1. So the next natural number in the sequence. So then let's consider the number we get when inserting m plus 1 into m. So we end up with 11 to the power of m plus 1 plus 1 plus 12 to the power of 2 times m plus 1 minus 1. And then we can rephrase it a bit as 11 to the power of m plus 1 plus 1. We leave it like this, and I will explain the reasoning for this in a minute. And then we have plus 12 to the power of 2 times m plus 1. And then our goal is to get as close as possible to this number here. So to have 11 to the power of m plus 1 involving here, and 12 to the power of 2 times m minus 1 involving here, because then we somehow would like to use the fact that we know that this number is already divisible by 133 and want to apply for our new number here in the bottom. So for this, we interpret this number as follows: 11 times 11 to the power of m plus 1. So we got rid of this plus 1 here by having 11 as a factor here. And we can do exactly the same here for the second term, considering that we can write 2 times m plus 1 as 2 times m minus 1 plus 2. And then we get 12 to the power of 2 times 12 to the power of 2 times m minus 1. So as you can see, this plus 1 became minus 1, so the difference of them is exactly 2, and for this reason we have 12 to the power of 2 here as a factor. And then we can rewrite this as 11 times 11 to the power of m plus 1 plus 144 times 12 to the power of 2 times m minus 1. And now you can see we have our terms 11 to the power of m plus 1 as here in our original assumption, and 12 to the power of 2 times m minus 1 also here part of our assumption. But this 11 and 144 are a bit disturbing here. So maybe you notice that the difference of these numbers is exactly 133, and we can abuse this fact here very nicely. So 11 becomes 144 minus 133. And then we have it times 11 to the power of m plus 1 plus 144 times 12 to the power of 2 times m minus 1. And this allows us to rearrange the term as follows. We have 144 here involved with our 11 to the power of m plus 1, And we also have 144 here involved as factor in front of 12 to the power of 2 times m minus 1. So we can rearrange all of this as 144 times, because this is belonging to this factor, times 11 to the power of m plus 1 plus 12 to the power of 2 times m minus 1. And now we are remaining with this term here when multiplying 133 with 11 to the power of m plus 1. So we have here still minus 133 times 11 to the power of m plus 1. And now this is divisible by 133, divisible by 133. This is also divisible by 133. Because it is some multiple of 133 here, the factor 133 is involved. And if we multiply a number which is divisible by 133, as we have it here, so this product ends up also being divisible by 133. So this whole term here becomes divisible by 133. And when subtracting a number which is divisible by 133 with another number that is divisible by 133, we have a number which is itself also divisible by 133. So this is divisible by 133, which proves our statement. Because we are done with our inductive case, meaning 11 to the power of n plus 1 plus 12 to the power of 2 times n minus 1 is always divisible by 133 for all natural numbers bigger or equal than 1. So if this was useful to you, please consider subscribing to this channel. Stay tuned for more videos, comment down below, and see you next time.